So, what are some of the unique challenges that you encounter when designing and rehabilitating pavements in different climates?
Uh, Largely it's the soil conditions. So, pavement engineers and geotechnical engineers tend to joke. Usually, a pavement engineer is looking at the top 10 feet. Geotechnical foundation engineers throw that away and deal with everything underneath it. Uh,
Yeah.
so, so
Pavement design is an essential aspect of infrastructure development, and it's especially critical in extreme climates where the elements can be unforgiving. When designed correctly, pavement can withstand the test of time and provide a safe and smooth transportation experience for users. But when it's not, the consequences can be severe, from costly repairs to even loss of life. In today's episode, we'll venture into the world of extreme climate engineering with Shawn Lapain, P.Eng, Senior Geotechnical Engineer at AECOM, as we explore how geotechnical engineers confront the toughest of challenges in pavement design and rehabilitation, from the blistering heat of deserts to the icy expanses of tundras. We'll uncover the strategies, cutting-edge materials, and groundbreaking techniques that ensure that roads remain resilient in the most unforgiving environments. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. And with that, let's dive right into today's episode. All right, Shawn, thank you for coming on the show. How are you feeling?
good, good. Thanks for having me.
Excellent, excellent. Appreciate you being here. So we're looking forward to this conversation. And in order to set the stage, it would be helpful if you could, share a little bit about yourself, talk about your career journey and what brought you to specialize in geotechnical and pavement engineering at AECOM.
Sure, that's a great question. Great start. So originally, I didn't start off as a civil engineer. I went to school in the States, in Detroit, as a chemical engineer. Had an opportunity to meet the civil faculty there and learn a lot about it. And then was fortunate to be able to do a co-op with a geotechnical firm in Michigan. That allowed me to travel all over the state, go to various construction sites, learn what it's all about, and had a great support system for that. And then it gave me a better appreciation for travel. So it seemed like a great idea to get paid to essentially go see the world. I was had that very big ambition to get out and put my name on something that was going to last and hopefully stand the test of time. So from that, I ended up moving to the Toronto area because at the time, the area where I was at, there really wasn't a lot of work, so I had to move out of town. And then from there, the firms that I've been a part of gave me the opportunity to travel within Canada. So, within a few months of graduating, they sent me to another province and let me go and be able to interact with contractors, and then it just kind of dominoed from there. I based a lot of my career decisions on essentially where I wanted to go and what I wanted to travel and do and see, largely selecting companies that had a very good profile and footprint in industry and through a lot of word of mouth. That took me to where I'm currently at in Ottawa, Canada. And I got the opportunity to start working for companies that were just starting out. So breaking into the industry, talking, working with people, and the job that we do here is largely people oriented, and I'm a very big people person. Being able to go through and talk to people, it's a heavy part of the job. So from there, through a couple of changes, it brought me to AECOM, and AECOM has been great. They've given me the opportunity to travel nationally and in some cases interact globally. So a very roundabout way of saying I wanted to travel early on, and my career they basically was built around that. And I've been given some great opportunities and then met some great people as a result.
That's wonderful. It's a great selling point for geotechnical engineering that you get to travel the world if you want to, right? So that's really awesome. That's really awesome. So what are some of the unique challenges that you encounter when designing and rehabilitating pavements in different climates?
Uh, Largely it's the soil conditions. So, pavement engineers and geotechnical engineers tend to joke. Usually, a pavement engineer is looking at the top 10 feet. Geotechnical foundation engineers throw that away and deal with everything underneath it.
Yeah,
So the unique challenges is what's already been there. So a lot of current pavement jobs that I do are rehabilitating existing infrastructure. So a lot of the jobs that we do are dealing, say, with brownfield remediation, being able to deal with complex soil conditions. So, for example, here in Ottawa, we have a clay that's very frost susceptible. It swells. So dealing with those heavy temperature swings are very important when designing your pavements. You're looking at your frost depth and then building your pavement accordingly. But the challenges lately, especially with this day and age, is climate change and dealing with environmental concerns. So a lot of professionals, clients, et cetera, that I've been working with in industry, they want to be able to get that bang for buck, but also to taking into account things like excess soil management. That's a big thing here in Ontario, whereby we want to try and be accountable for what we do, the carbon footprint, and so on and so forth. So it's no longer just a basically crack open a book and do a standard design. You have to take into account all those factors. And then finally, most recently in the last year or so, here in a lot of the stuff we do here in Canada, you deal with the Indigenous community component. So you have that cultural aspect, the significance of the land and how important it is to the local communities in the area in which you're working. So it's grown from just, okay, well, what do you have to deal with? Where do you have to import it into? How are you going to reuse what you have while still respecting the environment, the land, and the culture?
excellent. Oh, that's great. Lots to unpack there. Lots to unpack there. And when you think about, client service, how does client service influence your approach to project management and then also engineering design in general? And when you think about how you're approaching and leading teams from different disciplines, how does that all come together, especially when you're on complex infrastructure projects?
Well, that's a very multifaceted question there. So let's
I'll
see
break it
if
in
we can
pieces. Yeah.
break it down. So
Yeah.
in terms of client management, client expectations, you have to go into it not as you're the client as an organization that you're dealing with, the client as a person, because there's very different aspects of client knowledge. So you'll get the client that really has that experience, really knows what they're doing, what they want to see, and how they want to see it. And then you'll get the client that, well, they're looking after capital dollars and cents and OPEX costs, operational costs, and they don't really understand kind of what they're asking for in some cases. So you're not just designing to what the client is asking for, you're helping them manage their asset. So it's another aspect of the business that I've been involved in over the last few years, whereby the client is asking for something, but you got to read between the lines. Contractually, you have to do what you need to do to win the work, but then you have to sit down with the client and say, hey, is this really what you need? Is this really what you want? Because you may propose a technical solution. They may come back and say, well, I can't afford that. So being able to sit down and understand the needs, understand what you have to work with, and also understand what they're comfortable with is very important. If as a pavement specialist, if I'm going in and saying, okay, well, we're going to do cold in place recycling, and the client has no idea what that is, well, that's a huge risk item. So it's very difficult, but in terms of just a straight shot, simple solution, it's more so sitting down and working through the necessary steps. And then if you're really good at delivering the main base, then they're going to say, okay, well, this person really knows what they want, what they need to do, and what I want, and then they'll just keep coming back for repeat business. Now, just going back over in terms of project management, when I'm managing projects, as I also lead a team, I'm not willing to put my staff into a situation that I wouldn't be comfortable doing myself. So a general rule of thumb I have when managing clients, when managing teams, when managing staff is always be willing to work side by side with them. There's never that leadership separation where I'm up here and they're, down below will go out and do it. You're always, when it comes to staff, you're always mentoring, you're always teaching, you're always helping them grow, always being available. But one of the key principles I like to be involved in and helping them is saying, okay, well, I can't I can't help you by always giving you the answer. I want you to come to me with solutions and always be upfront and honest. If you can't do something, or if you're not able to manage certain things, work with the people rather than against them. That's the worst thing you can do when managing and leading, is going in a direction without listening to your support staff and the people that are with you. So it's very important to understand that this is very much a team sport. It's not a me, it's a we type of situation. Now, that's just dealing with the client and the immediate discipline. When you're working in multidisciplinary aspects, communication is absolutely key. So being able to stay ahead of the game, you don't want somebody to be finding out, okay, I didn't design it this way, or there's an issue with the mixes, or there's a soil condition that we didn't encounter or didn't anticipate. You're always having to walk people. It's a journey. So when I'm working with multidisciplines, I'm always ahead and saying, okay, well, you've seen this. Well, how are you looking? How are you doing? It's very much a client service, kind of like, the hospitality industry. Engineering is very much a hospitable service, and that we are servants to the client, not in a subservient way, but in terms of they're if they're content, that'll keep you in business. If you're communicating, that'll keep you in business. The moment you go against all that, that's when the phone stops ringing and the door's shut.
Very good. Thank you so much. You're absolutely right. And you can control what you can control. You can't control what you can't control. So that communication is so key. And I think that folks do themselves a disservice when you have bad news and you wait to tell it because you don't want to share bad news. But it's like you get it in front of folks and you make a decision as a team. So thank you for sharing that. It's really
My
helpful.
pleasure.
Yeah. So what are some of the advancements in pavement engineering that you've seen recently, and how are they changing the industry?
Slowly but surely. So here in Canada, we still do traditional borehole investigations on a lot of
Okay.
our projects because of a lot of the risk introduced in these new methodologies. Over the past 10-15 years or so, ground penetrating radar has been an up and coming service. That's usually managed a lot by geophysicists, but they do require heavy input from geotechnical engineers, pavement specialists, to be able to properly understand what's needed. So ground penetrating radar, I'm seeing, is being used in many different aspects now. Here, particularly in Ontario, for a lot of our urbanized infrastructure, we're using that to get a better continuous profile of roads, whereby it's not always practical to go in and deal with a 100,000 plus ADT roadway where you have to shut it down at night. You have a very tight window, so you can't always go out and drill things. Where I've found it's been extremely beneficial with advancements in technology is being able to understand where you have buried infrastructure. So most often than not, when you're seeing or doing work, because I've seen it used in dam projects, I've seen it used a lot in road projects. It helps better understanding your mill and overlay profile, or from a heritage nature. The other aspect that it's now being used a lot, and I've seen on various projects, is it's being used for utility locates. So traditionally, you'd have your wand that you'd go out and you have to tie into things, but with ground penetrating radar, it's now being used to give you a better idea where your infrastructure is due to the change in density you're seeing from your scan profile. There was one other thing that I've seen. There's one subcontractor that I've listened in on for technical. They're starting to use it in assessing density profiles, so for compaction. So traditionally, I don't know if you've experienced this over in Philadelphia, but you would typically use what's called a nuclear densometer. Here, they're trying to use it to basically give you a continuous scan, because when you're doing nuke shots everywhere, you're only getting that area where it's scanning, and it's also using isotopes, so I mean, it can be hazardous after a point. So that's kind of a very long-winded way of saying that even though ground penetrating radar has been around for a while, it's being used in new and innovative ways to further reduce our time in the field. traditionally with a borehole investigation, you're looking at, months, weeks to months plus. With ground penetrating radar, you can reduce your borehole investigation and be able to not only have a more focused investigation program, but what that'll do is that'll give you less time in the field, more data at the end of the day, if used right and understand, you can interpret it correctly, and a better, more robust design profile to the client in question. Now, that's not the only thing that I've seen. Is there's slowly becoming advancements in material. So a big push right now in industry is low carbon concrete. A lot of research is going in to reduce the carbon footprint in how we construct roads in particular and how we apply and use concrete. So a lot of suppliers are sinking in money into low carbon concrete to get a better environmental footprint from a carbon counting perspective, but also seeing if you can elevate your structural profile with that. So it's still very much in progress, but it is something that is going to be coming out more so in the coming years. And finally, the last one that I'm starting to see more on is aerial drone survey, being able to survey highway alignments, going into more difficult areas such as dams. Even I've seen some experimentation going on with going into airfields. So the effort with that is to be able to collect a huge amount of data without impacting operations. So a big focus, and it's always, I wouldn't say always, but it's traditionally been, is trying to get the necessary information without impacting operations. So those are three good examples of technology that is slowly changing what we do as engineers and on construction projects as well.
It's exciting to hear what's forthcoming and what areas people should be looking at to advance their careers, or even some of the folks listening are looking for research ideas. That's really cool to see what is out there and what's on the horizon. So thanks.
No
Now,
problem.
when you look at pavement rehabilitation projects, how do you ensure the success of these projects, especially when you're dealing with unknown subgrade conditions? I mean, what are your thoughts there?
It's all about risk mitigation at the end of the day. We're only limited by what we can see. There's always unknowns between data points that we're collecting. So being able to balance that fine line between optimization of a project, cost implications, as well as risk mitigations is very important. Understanding that when you're designing your pavements, your technology and knowledge will get you very far, but being able to protect yourself from surprises that you're going to find from design to construction is very important when serving your client as an engineer. You're there as an advisor at the end of the day, so you're advising them. This is what we know. However, when you're budgeting and developing and guiding your project, you always got to plan for the right amount of contingency to deal with those unknowns. Otherwise, if you tell the client everything's successful and everything's hunky-dory, you end up digging yourself into a corner, pardon the pun.
Yeah. Excellent. All right, great. Yeah. What role does falling weight deflectometer, or FWD testing, play in your pavement investigations? And how do you utilize that data?
So it's very much a supporting technology. Outside of the markets that I've operated in, sometimes it's used as a constructability measure to, or even a mechanism in which it can be detected whether, say, like the contractor built the road correctly. So right now we use it to complement our borehole investigations. We meaning the industry. So where I've used it myself, I've gone out and done before and after testing out in Seattle. Did the roadway infrastructure out there for a project once upon a time before my time at AECOM. Other ways I've seen it is in doing void analysis. So I did a project a long time ago at the Delaware River Bridge, whereby there were voids underneath the concrete pavement at the bridge crossing. So the goal of the test is to go through and say, okay, well, what's my baseline? And then after we stabilize it, was there any improvement? Now, traditionally, especially, we have what's called composite pavement here. For the people listening to this, it's a two lift, a thin asphalt overlay under about 6 inches, 4 to 6 inches, and then you have your concrete base underneath, and then you have your granular fill, and then your subgrade. So traditionally, when going out and testing either a rigid or a composite pavement, you would look at what's called load transfer efficiency between your joints. So typically, when dealing with high volume infrastructure or traffic going through over a pavement, your joints will fail over time. So being able to understand, okay, am I going to get the same loading and approach and leave of the joint is needed, and that's why FWD is used. In addition to that, using FWD for assessing shoulder strength is another application for projects that I've used it on. Quite often than not, for construction staging, you're using your shoulders to hold sometimes heavy amounts of traffic. So in doing that, you need to have a good understanding of what's there. And drilling those areas doesn't give you the right amount of information all the time. You can do a ton of FWD testing to complement and correlate to your borehole data to give you an idea of what your subgrade profile, your resilient modulus profile is from one limit of your job to the next. And finally, we've used it, high capacity HWD deflectometers to simulate varying loads on airfields. So it's largely used on concrete pavements. I've seen some instances where also too, if we're doing bush roads up in the north, where it's a very low volume roads, or it's surfaced roads. Sometimes if you're going through a swamp, to get that deflection basin is also quite valuable using that equipment. Where it could potentially go is as clients get more data or more historical information, we could see like where overseas where they can use FWD, just go through, thump it, and then compare it to historical information to analyze trends. It's a very good asset management tool. However, currently it's just not quite there where it'll replace the need for our traditional intrusive investigations.
Got it. Got it. Well, thank you for that. Well, probably provide some links in the show notes for people to get more information about that, the
Sounds great.
test itself. All right, great. So let's see. You've worked across Canada, you worked across the US. How has that shaped your approach to geotechnical engineering?
No two sites are alike, and no area is the same. You have to approach each area as if it's something that you're seeing for the first time. You've got varying sensitivities depending on where you go, but also too, whereas your experience will help you as a geotechnical engineer across the country, or even across the continent for that matter, you have to really do your homework, really do your research, ask the right questions to properly understand what you're working with. Although I think over time, doing boreholes and lab testing will greatly reduce from the frequencies I'm experienced with. I can't see the need to totally eliminating that
Yeah.
because of the fact that, even though your subgrade may not change, your anything above and beyond it, from an engineered fill to a placement of materials, that can always be different. So the engineer that designs and provides recommendations still needs to go out and then get their hands on that and essentially get their boots dirty to be able to better understand what you're dealing with. Otherwise, it could affect how you recommend treatment or design to a client, and it could get you into trouble.
Got it. We don't want to be in trouble. So excellent. Let's see, switching gears a little bit. What would you say is a key leadership lesson that you've learned throughout your career that's had a lasting impact on how you lead today?
That's a really good question. In terms of leadership, as I said earlier, always listen to your team. Everybody, regardless of experience, your youngest engineer could have, the best idea, or an idea that somebody with 50 years of experience may not have thought of. It's just life lessons and exposure can really help shape you as a leader. Always be willing to listen to the people around you, because there's no such thing as knowing it all and doing it all, and being able to understand it. This is, as I said earlier, this is very much a team sport. You're only as good as the team around you.
Excellent. Before we take our break, final piece of advice you want to give to engineers that are just starting out in their careers in geotechnical and pavement engineering?
Love to travel. If you love to travel, this is definitely the career for you. Never never be happy with what you have. Always strive to get more. Never assume you need to stay where you're at. Always look to the next adventure, the next step, and above all, always have fun. If you're not having fun, it's just punching a clock in another day at the office. This is a job that you really can succeed in if you're passionate about it, and if you go to work having fun at what you do.
I love it. I love it. That's a great note to end on, or pause on, I should say. So we're going to come back in just a minute, close this one out with Shawn on our career factor safety in segment. Stick around. All right, welcome back. It's time for our career factor safety in segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your engineering design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Shawn Lapain, P.Eng, Senior Geotechnical Engineer at AECOM. Shawn, you've had a very successful career. And if you just pause for a minute and look back at your career, what's something that you've implemented in your career to give yourself, let's call it a factor of safety in your career?
Good work-life balance. So originally on, and something that I had to learn over time, is being able to balance deadlines and needs, and being able to ask for help. That is one of the hardest things an engineer can do. It's very hard for us to say no, especially to clients. It's very hard to, because in that regard, it's always a concern that, if you say no now, will they come back to you later? So when doing that, and in something I've learned over time, and in some cases learned the hard way, is being able to say, well, no, I'm too busy, or I've got a lot on my plate. I need to focus on the deliverables that I have right now, and being able to balance that. So I would say that is probably the one big thing. And then having, as another factor of safety, being able to have that outlet, not feeling that I have to park my butt at my seat, 8+ hours a day, working through the night to try and meet deadlines, because reputation is basically what we have to sit on, and what is important to us, because your reputation will carry you very far in industry. If people know that you're really good at what you do, you'd keep trying to shoot for the stars on that. So even recently, and I'll thank my wife for that, is I get told at least once a year I have to take a break. So planning that vacation, having an extracurricular activity. So for here, we've got great mountains and then trails. Taking up a hobby that will help you disconnect, or even if you've got meetings or calls, don't be afraid to take it out on a trail. Don't be afraid to go for that ice cream, and be able to get up and walk away. If you sit down and just crank out reports and then get on meetings, it will definitely affect you mentally, and it will definitely downgrade your effectiveness as an engineer over the course of your career. So being able to take breaks, and being able to communicate with your team, your superiors, and say, hey, we're very successful right now. I need help. I need to be able to get the necessary tools to do my jobs safely, to do my job well, and to also protect my mental well-being at the end of it. Because if you're not careful, this job can easily overwhelm you if you don't have those key elements at your disposal.
Wow. Really, really, really good stuff here. Thank you so much, Shawn, for coming on, sharing all these great insights with us. You shared information and advice I know is going to be helpful for our listeners and those that are watching. if somebody wanted to reach out to you, what's the best way for them to find you? On social media or an email you want to share? We'll put in
Yeah,
show
social
notes.
media is fine. I'm pretty active on LinkedIn.
Okay.
That would probably be the best way. I usually monitor it daily, so I definitely don't mind having conversations, discussing careers and things like that, and always on the look for new staff. So as a manager, LinkedIn has been a great tool in meeting people and growing a team. Met a lot of very interesting people that way, and it's always great to hear what people are doing in different parts of the world.
Excellent. Thank you so much. It was really good to have you on the show. I really enjoyed talking with you. Thank you.
My pleasure. Thank you very much.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as any links to any resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.